Hi, I'm Dr. Jimmy Baber. I am the Dean of Advanced Technology and Public Service Careers here at Washington Community College. In our division, we have HVAC, welding, manufacturing, robotics, transportation, criminal justice, and early childhood education. Welcome.
Hi, I'm Al Leitz. I'm the Director of the Advanced Transportation Center at Washington Community College, and I want to talk to you today about battery electric vehicles. I'm standing next to a Ford Mustang Mach-E battery electric vehicle. The automotive industry is quickly changing over to battery electric vehicles in order to reduce carbon emissions and get better fuel economy, to reduce our fossil fuel usage. Today, product development for battery electric vehicles is at an extremely high demand, and the servicing of these vehicles. Technicians and engineers are required to do this work, and we're training people here at Washington Community College to do the work on developing these vehicles.
Hi, I'm Alan Day, and I'm a faculty member in the Transportation Technologies Department. I teach classes like the class that's behind me, Automotive Dynamometer and Test, where students learn to make wiring harnesses and instrument engines that they're going to run on engine dynamometers later in the semester. The students are learning these skills because our employer partners in the region at research and development and technical facilities require the students to have these skills. And these skills are different than a technician that's just learning to work on vehicles to do diagnosis and repair, because they have to build harnesses, put the pins in the connectors, vet the work that they've done, and actually get the engines to run. And that's important for when they work in technical facilities as well.
My name is Bob Lowing. I'm one of the full-time faculty in auto body repair, which is now part of the Transportation Technologies Division. And maybe a little background on what we do here. Maybe what's changing in the industry, what we're kind of concentrating on. One of the big things that we really have to be mindful of is the materials that we're working with today. Cars are changing to composites, different types of steels, different types of ways to manage energy, different types of sensors. And one of the things that we've really done in the last maybe 2 or 3 years is really concentrate on some of those materials. Behind me right now is an autoclave, and you might ask, what do we do with an autoclave in auto body? And the answer would be is composite materials, Kevlars, fiberglasses, and basic carbon fibers. And a lot of this stuff is present in today's vehicles, and learning how to work with it and how to repair it is paramount. Okay, off to my right shoulder here is a welding station. So primarily we concentrate on sheet metal. This would be steels, this would be all kinds of different high-strength steels, ultra-high-strength steels, and how to repair them, and the process to put all those back together using ICAR standards. And then just recently we really saw a need for aluminum repair. So a lot of aluminum out there, more coming, and processes of putting that stuff back together, rivet bonding with adhesives, and then and getting into actually repairing the panels, the aluminum panels. And then the last thing would be aluminum welding. So many different aspects of welding aluminum, thin metal to thick metal, all kinds of different aspects of repairing the vehicles, and everything right today is about lightweighting. So lightweighting the vehicles is very important. So that's kind of our concentration, that's kind of our direction as a department, is dealing with all the new materials and all the repair processes that go with it. And then on top of that, all these sensors and all the different aspects of repairability after that car has been in a collision. So those are the big things that we really concentrate on in auto body repair.
So my name's Sean Martin. I'm the robotics instructor here at Washington Community College as part of the mechatronics program. So in the robotics program, we teach how to set up and program industrial robots. It's a high demand field for robot technicians and automation specialists for manufacturing. Basically, anything that's made today has some sort of automated system that builds it or assembles it in some way. So the idea behind the industrial robots is they have different types of tools and grippers and things that you can place onto them. And we're going to teach you how to actually program this robot to go through different processes, to go through different applications, and to actually set up the robot and use it. We also teach how to integrate the robots with other automated systems. So for example, things we'll teach are like how to set up offsets for the tools, using different things like pointers. We have trainer boards set up with different types of sensors and automation. So the robot can go through and pick parts, it can do sequencing. The robots are connected to other cabinets, so they can be communicating with other automated devices. We go and we integrate things like solenoid valves and other types of industry devices that you commonly see out on a plant floor. We also train on safety, so like I'm wearing safety glasses, because that's something you gotta wear all the time on industry. So other things too, like, so these robots are basically, even though it looks like a small tabletop robot, the programming is the same on this robot as it is on a large robot. Even the programming for these robots is similar to collaborative robots that are forthcoming. So with these robots, they have to be caged in that when they're in industry to run them at full speed. With collaborative robots, they're actually designed to work with humans. So for example, if this were a collaborative robot and it was moving, by touching it, it would actually stop. And their speeds are also limited in order to be considered a safe speed. So with these classes, the robotics classes, the goal is to help train you up for jobs like robotic technician jobs and automation specialist jobs that you would apply for at either end user facilities or integrators. Integrators are the ones that actually build the robot work cell systems. So the idea behind this is that as you progress through the classes, you learn more about how to not just to jog the robot and make a simple program, but do more advanced software options these robots have, safety software options to set up to help prepare you for a job as like a robot technician and automation specialist in the field.
Hi there, my name is Andy Dubuck. I'm an instructor here at Washington Community College. I teach CNC Manufacturing, which is what you find right here behind me. In these classes, we teach the whole process for bringing a workpiece from start to finish, just like this item that's located inside the machine behind me. So we start out with a design phase using a 3D printer. This particular part is an upright for an off-road racing vehicle. So we design it first using CAD software, and then we bring it out to the CNC machine and we create the actual finished product. This is a crucial step in the manufacturing process because we go all the way from the design, the prototyping, all the way up into mass production using the exact same type of machinery that you would find in industry. And then this part would be fully functional and ready to go onto a vehicle. So all of our courses are designed in that way using our state-of-the-art lab equipment, and you will be able to go all the way through the processes I've laid out right here. This is a perfect example of the type of manufacturing that we see in today's industry because students will be able to take their skills and go nationwide to any type of employer that has manufacturing process like this, whether it's an automotive facility or aerospace or any type of aeronautical component for shuttles or for SpaceX or any component like that. These are the type of skills that are widely transferable because all different industries use them, including automotive, defense industries, aeronautical industries with space flight and other types of commercial space programs. All these skills are transferable to other institutions. If you're interested in a higher degree, you come here to Washtenaw to learn all the hands-on components and how to run the equipment and how to build the parts. And then a higher level class teaches you how to design the parts and analyze them and refine them into better and more simpler forms. Washtenaw Community College is an excellent place to bring that together, and as a graduate myself, I had a lot of fun, and I'm sure you'll have a lot of fun too.
My name is Alex Paskowski. I'm a full-time instructor here at Washtenaw Community College in Ann Arbor, Michigan. I'm also a co-chair of the department. Our welding program is one of the largest in the country. We typically enroll between 500 and 600 students. We have 72 welding booths, 60 of those are hardwired. Our program is linear. We teach our students everything from the basic manual welding processes all the way up to advanced automation and robotics. We teach laser welding and cutting, CNC plasma cutting. We also have a specialty in inspection and testing, so we teach a lot of both destructive and non-destructive testing. We teach X-ray, both traditional two-dimensional X-ray and CT. So 3D X-ray. We teach ultrasonic testing, both traditional angle beam ultrasonic testing and phased array ultrasonic testing. But we're able to cover a lot based on where we sit in Michigan, being that we're in the middle of a lot of automotive businesses, private industry. We have aerospace. We have military contractors around here. So we're able to feed a lot of industry. Our program produces 21% of the welders in the state of Michigan, so we've been pretty successful at turning students into welders. So we are an ATF, so we're an accredited testing facility. We are all of our full-time instructors are able to issue AWS weld certifications. We don't require that as part of our program exit, but it is something that the students usually strive for, so we do offer that as an option for them. In terms of occupational demand around where we are, we have automotive, we have the union trades. Through the program, we offer an ironworker pre-apprenticeship program. We also offer a transfer agreement to Wayne State University, which is a 3+1 program, so the students can do 3 years here at the college, 1 year at Wayne State to get a welding engineering degree, which has 100% job placement. In terms of our jobs for students that graduate from our program, depending on the skill set of the student and how far they get in the program, typically our students graduating with our basic certificate will earn somewhere between $15 to $20 an hour, and our more advanced associate's degree seeking students that are higher skilled have earned as much as $40 an hour coming out of our program. So we always go by the motto of your input equals your output, so the more time you're able to put into this, the better you're going to be in the long run.
Hello, my name is Zach Van Buren and I am an Advanced Driver Assistance Systems Technician at Toyota. What I do really focuses on the advanced driver features that you see now more than ever between cameras, sensors, and radars. That's what I do for a living. And without the training I got at Washington Community College and really the focus on mobility and preparing everyone for the future, it's not a stretch of imagination to say that I wouldn't be where I am today. Being able to come here without really knowing what I wanted to do, but have the instructors and the system that helped me put my hand on the vehicle, experience what it's like to work in the field and in the industry, helped really guide where I am today.